Hi, this is a quick video to show you how to answer the questions for the extended version of chemistry, chemical reactions. Now, the difference between the extended version, okay, and the core version is that you really have to think quite a bit more for these questions. Right, so let's get started with the first one. When a metal carbonate is heated to a high temperature, a chemical change takes place. Now, this one you should know. We did talk about this one in quite a bit of detail. Okay, and it is a thermal decomposition. Okay, this is the apparatus, and we talked about this reaction, and we talked about how the Bunsen burner heats the copper carbonate, and the green copper carbonate turns into black copper oxide. It produces a gas. They show you the bubbles here. They show you the bubbles coming out of this delivery tube, going through the lime water. And the other thing that happens is that the clear lime water turns into a milky liquid. Okay, now we did also talk about if you do this reaction for real, what you must remember to do is take away this test tube before you take away the Bunsen burner, because then as the temperature in this boiling tube, as it drops, it creates a vacuum which pulls water back up this delivery tube. If that goes into this very, very hot test tube, you can get an explosive boil, and this could shatter the test tube and you get bits of glass flying all over the place. Now, having said that, this next question that says write down one safety precaution that should be taken, the one that's always the best one is, okay, goggles. If you want to, you can call it eye protection, you can call them safety specs, but that's always worth 1 mark. Okay, the other one that's also a good safety precaution is the one about remove test tube. Okay, remove test tube before heat. Okay, remove the test tube before the heat. So either of those are good safety points. There are some others. You could also say tie hair back, tuck away ties, that kind of thing. But the most important one is the eye protection. And this one about removing the test tube, that's also a very good safety precaution. But there's a number of things there that will get you the points. Okay, so this next one. Describe one change you would expect to see during the experiment. Well, there are two, but you've got to describe them, okay? So there's the important word there, describe. You've got to say what you would see. That's what describe means. Now, the two things that will get you that mark, the first one is you'd have to say lime water goes, okay, from clear to cloudy. Okay, so what you've done is you've said what it is, what it's like at the beginning, and what it's like at the end. So you've described clearly what the change is and what it happens to. Okay, now there were some people answering this question and they were saying things like, it goes from green to black. Well, what goes from green to black? You've got to say exactly what it is that changes from green to black. Or some people said it goes cloudy. Well, what goes cloudy? And what was it to begin with? Okay, so you've got to give more detail. This is the whole point about the extended questions. So the other thing that you could say is you could say green, okay, copper carbonate, CuCO3, goes from green to black. Okay, so that is what the change is, okay, and what it happens to. Okay, now for either of those two, you'll get the mark, 1 mark. The next one, complete the equation for the reaction. Now, because this is the extended version of the exam, you've got to be really correct with this, okay? Now the answer is, to complete it, it's CO2. Now there were some people who did this. They put CO2. Okay, that is completely wrong. This is the answer. There was also, I think, somebody who put CO2 like this. Okay, that's also wrong. You've got to get that 2 in this kind of position here. Okay, it's called subscript. Right, now that is carbon dioxide. This is not carbon dioxide, and this is not carbon dioxide. Okay, that's got to be right. There's also a little clue here. Okay, it tells you that it's a gas, and you should also remember from this, there is a gas. Okay, now that's important a little bit later on. Again, you've got to be thinking a bit cleverer. Very often you get given more information in an exam paper than you think. They'll give you lots of clues that sometimes you don't spot. Okay, so we'll talk about that in a minute. But moving on. Now, with this next one, so the test tube and its contents were weighed at the start and at the end of the experiment. And here's the results. Okay, so the mass of the test tube and the contents at the start is 32.5. The mass of the test tube and the contents at the end, 28.1. So it's gone down. Okay, so the change now, because the mass has gone down, the change, it's a negative change. So it's a minus, and I think it was a 4.4. Okay, but you've got to get this minus. Okay, you've got to make it really clear that this was a drop in the mass. Okay, you had to get that minus to get this mark. The next bit, use the law of conservation of mass to explain your answer to part E. Well, firstly, the law of conservation of mass is that the mass of all the chemicals that you have at the start is equal to the mass of all the chemicals that you have at the end. Okay, now that's the law of conservation. All the material, the mass that you had at the start, is the same as all the mass that you had at the end. So having said that, why does this appear to drop? Well, if you didn't remember it, you've been given lots of clues, and there it is. Okay, it's a gas, and because it's a gas, and there it is again. Okay, there's the gas. So the mass of material in here, the test tube plus chemicals, that is going to drop because some material, okay, is going down here, and then it's coming out of the test tube and it's going into the air. So the mass of this test tube plus the chemical in here is going down. Why is it going down? Because it's escaping as a gas. So you can say CO2 escapes as a gas. Okay, and that the CO2 weighs 4.4 grams. Okay, and you get a mark for that, and a mark for that, and a mark for that. Okay, next one. Ethanol is a fuel. Now, if you didn't remember, ethanol is the alcohol. Anything with ol on the end of it is an alcohol. So methanol, ethanol, okay, these are all alcohols. And here's the chemical formula. Okay, so there's 2 lots of carbon, 2 lots of hydrogen, 1 lot of oxygen, and then another lot of hydrogen. When ethanol burns in oxygen, so that would be adding O2 to it, heat is released to the surroundings. Okay, First of all, name the elements present in ethanol. Well, there's carbon, there's hydrogen, there's oxygen, there's hydrogen again, but we've already got hydrogen. So, and now it says name the elements. Okay, so we'll put carbon, hydrogen, and oxygen. Okay, and just so that you can remember, it's OXYGEN. Right. Predict the products of the combustion reaction of ethanol. Well, if you have carbon with oxygen, okay, those two, that's going to give you CO2. It's going to give you carbon dioxide. The only other things we've got in here, we've got hydrogen, and if we combine that with oxygen, okay, we're going to get H2O, carbon dioxide and water. They're the only two things that we can make. Okay, C, H, and O with O, they're the only two things that we can make. Okay, so your prediction is carbon dioxide and water. Next question. Explain why this reaction is also an oxidation reaction. Well, it's because it's ethanol combining with oxygen. Okay, so you can put in here, this is an oxidation because the ethanol combines with oxygen. Okay, oxygen. There we go. Okay, now the final bit, and this is about displacement reactions. So we have magnesium metal with a copper salt and a zinc salt, copper chloride, zinc chloride. And the magnesium reacts, well, you wouldn't expect it to react with magnesium chloride because that's already reacted with magnesium chloride. But it does react with copper chloride and it does react with zinc chloride. Okay, so this one reacts with two things. The copper, you wouldn't expect it to react with copper chloride because that's already reacted with copper. So you wouldn't expect this one to happen. It doesn't react with magnesium chloride and it doesn't react with zinc chloride. So copper reacts with none out of those three. And zinc, well, again, you wouldn't expect zinc chloride to react with zinc because it's already reacted with zinc, but it does react with copper chloride. So zinc reacts with one out of these three. Now, the question says compare the reactivity of these metals. Use the information in the table. So what you've got to do first of all is say which is the most reactive. So you'll say Mg, most, Cu, least. Okay, and you're going to mark for that. And the reason why is Mg reacts with two chemicals. Okay, you might need a little bit more space here. And Cu reacts with none. Okay, so you've used the information from this table, yeah, and you've said which is the most reactive and which is the least reactive. So you get the 2 marks for those questions. Okay, now the symbol equation for the reaction between magnesium and copper chloride. Well, the first bit is not too difficult because there it is. Okay, there's magnesium chloride. So you're going to put Mg plus, oh sorry, copper chloride, there we go, CuCl2, CuCl2. Okay, now what's going to happen is these two are going to swap places. Okay, the magnesium and the copper swap places. This is a displacement reaction. This is where this one pushes out this one. So on the other side, we're going to get copper by itself, and we're going to get magnesium chloride. Okay, MgCl2. Now you get 1 mark for that bit, and you get 1 mark for that bit. Okay, and that is the extended chemical reactions exam paper. As I say, the important thing to remember is you need to think more and you need to describe in more detail. Okay, remember that and you'll do well with the next extended paper.